So in this part of the statistic, after you already learn how to represent data on the various tools like pictogram, bar chart, line chart, okay, we need to learn how to evaluate the statistic. So for example, here, this table is showing you the advantages and the disadvantages of each of the tools that we discuss. So like for example, for the pictogram, it's actually visually attractive because you're using icons, so it can catch the reader attention. So it's actually very easy to read from a pictogram. Okay, but of course the disadvantage will be, right, it will be inaccurate for very detailed analysis. If we want very detailed information, we cannot get it from pictogram. Okay, so that is the pro and the con, advantage and the disadvantage. Okay, for the bar chart, it's actually very easy to draw. Okay, and then it's easy to draw and then it's easy to compare because we'll be looking at the height of the bar. Okay, but the disadvantage will be, right, it doesn't show the proportion. So for example, it doesn't show that the first bar is a certain percentage of the total. It doesn't show. We just know that for every part of it, okay, this is how much. Okay, so it doesn't show the proportion. Okay, and for line graph, it's good that you can actually see the trend over time. Because for a line graph, it's very easy to see whether the trend is like going up or is it like coming down. Okay, so one good thing about using a line graph, if we want to show the trend with regards to time, so it will be good. Okay, but again, it has the same disadvantage as the bar chart. It doesn't show the proportion. Okay, so this tool has the same disadvantage. Okay, where else for the pie chart? Okay, so if we have gone through the representation of the pie chart, you realize that the good thing about pie chart is, right, from the pie chart we can see the proportion. So for example, we can see like, a big portion of the people like this thing, the amount, the people who don't like a certain thing. So we can see the proportion because in a pie chart, the bigger space it is, the more popular is it. Okay, but one bad thing about the pie chart is, right, it's actually not easy to draw. And I think I did mention in one of the previous example, if you got a lot of category, it's not feasible to use a pie chart because a pie chart is limited by 360 degrees. So if you got like 20 categories, it's not feasible that you divide the pie chart into 20 categories. Okay, so these are the basic pro and cons. Okay, so if you want a more detailed one, you can always refer to your book to read about the advantages and the disadvantages. Okay, so for this category of question, you'll be asked to about why certain statistical graph are not are misleading. So this part is important. So you'll be asked whether how come it's a misleading feature, how come the bar chart is misleading, all this. So these are the few things that you check. So for example, the first thing, we got to check that the scale on both axes are even. Actually, I'm going to cancel the word even. Okay, I'm going to change it to uniform. So what do we mean by that? So later on in example 7, right, it'll be something like this. So if you look at the interval, every interval are even here, are uniform. Okay, can you see? Every week we got the same interval. But for the horizontal axis, right, it is not. Can you see this part is like 15 centimeter? And then this part is only like 5 centimeter. So this is called uneven. So if it's something like drawing model. If your model is not even, it's not uniform, okay, like your 2 units is actually bigger than your 1 unit. Okay, your 2 units is actually smaller than your 1 unit. Okay, then it doesn't make sense. Okay, so that's the first thing you look out for. And then another thing that you look out for will be sometimes the axis doesn't start from 0. yeah, you will see things like that. It doesn't start from zero. So when it doesn't start from zero, right, it's actually a bit misleading and it's a bit unfair. Okay, and another thing will be the size of the icon and the bar chart. Okay, so for example, if you are looking at bar chart, uh, it should be the same width in the bar chart. So the only thing that's not the same, right, is actually the height of the bar chart. Okay, so but then, right, it will be very misleading, right, if our bar chart is like this. Sometimes it's fatter, sometimes it's thinner. It's very confusing. So in a bar chart or in a pictogram, right, the you should have like a uniform width. Okay, that happens most of the time. Okay, and this one is not very frequent. If you got three-dimensional representation, that means sometimes they use a 3D pictogram. Okay, so that one is a bit misleading because it's three-dimensional. The item that is nearer to you will seem bigger, but in actual fact, they are not supposed to be bigger. Okay, so when we want to look for the misinterpretation of a statistical graph, these are the few things that we check out for. So like for example, in example 7, okay, we are trying to measure the height of a plant and then they record it every week. So we want to see the trend over the week. So remember, a line graph can show the trend over the week. So in this question, right, okay, it looks like if you look at the trend, it looks like the plant grew quite a bit. If you look at the trend, okay, and Randy claimed that the height in week 1 and week 5 quadrupled. Quadruple is like 4 times. So we need to justify whether his claim is valid or not. So how are you going to justify, right? So you look for the height in week 1. If you look, it's actually 15 centimeter. Then you look for the height in week 5. Okay, that is 30 centimeter. So if you look, it's actually only double. So the height actually doubled. It doesn't quadruple. Quadruple is like 4 times. So that's why his claim is not valid. Okay, one reason why he claimed that could be, the reason why he claimed that, right, is because of this reason. It's because of this reason. Because there is an uneven interval. So this part is uneven. So because of this, right, if you look, it looks like it jumped 4 times. Can you see? So some people will feel that it actually multiplied by 4, but it actually didn't. So the misinterpretation come from uneven scale. So if there's anything misleading on this, the misleading feature in this question will be the uneven scale on the vertical axis. Okay, and okay, the question didn't ask for the misleading feature. I'm just adding it on for you. Okay, so the way we answer them is we get the real data and we compare. Okay, and then in example 8, okay, it's an annual report of a company that sells tins of chocolate malt drinks. So we are comparing 2 years. And the report says that if the drink has doubled, the sales has doubled. Okay. But if you look at the picture, right, why do you think it's misleading? Okay. The reason why is it misleading is the height doubled. Do you realize the height kind of doubled? But then, right, the width is also doubling. So if you want to illustrate this feature, you should just be drawing something like this. You should just be drawing something like this. Okay, my diagram a bit not nice. So you should keep the width the same. So only the height should be the one showing you that it doubled. Okay, so how can this be a misleading statistic? Okay, the width of the icon, the width of this icon doubled as well as the height of the icon. So it will be confusing, right? Whether should you be looking at the height or should you be looking at the width? So there's a lot of exam questions. They twisted the question to match the idea. So this one fall under point number 3, point C. The size of the icon should be the same. So it's like it should be the same with the size. So the height can be different to illustrate the difference in the statistic that we're trying to show. So these are the few things, but when you answer this kind of question, right, you got to base on the context. So later on, when you try to do the practice question, so for example, okay, you got to fit certain, you got to fit the context of the question. So later on, when you, for example, when you go to practice question 9, it is talking about pie chart. So this pie chart shows the types of food that Michelle is going to serve at the 1-month party. So she's serving 3 kind of food. Okay, but and we know that it's like 20%, 22% is potato salad, 45% is apple strudel, and the chicken puff is 33%. Okay, so it looks quite clear to all of us. Okay, if I go to this party, I got 22% potato salad, I got 45% apple strudel, I got 33% chicken puff. But what is misleading? Okay, the misleading feature here will be we do not know whether the percentage, okay, we do not know whether the percentage of food, whether it goes by quantity or mass. So when they say 22% salad versus 45% apple strudel, so is it like serving? Okay, so maybe like here we got 44 serving. So does that mean that here I got 90 servings for the apple strudel? So I don't know whether it goes by the quantity, the number of potato salad, the number of apple strudel, or does it go by the mass? How heavy is it? So this can be confusing. So maybe it goes by mass, and when I go there, right, maybe the potato salad is just a few servings because potato salad can be quite heavy. Okay, so like for example, in this context, the confusing part is we will not know whether the percentage of food goes by quantity or go by mass. So that's a confusing part. Okay, so when you answer this type of question, you got to answer it in terms of the context. So just be flexible. Okay, you can add in any logical things, but these are the main guidelines. So even when you go to Sec 2, the statistical graph in Sec 2, right, we also go by this kind of basic guideline.